When I got started, I was not familiar with any of the three forms of liquid cooling. The first system was a flagship system. Initially included some engineering prototype hardware. That was a great learning experience. It was a cold plate based solution that also had in-row cooling to make the system close to room neutral. We learned a lot of things along the way with this engineering prototype system and then deployed a production system a few months later. We also did a project converting an existing air-based cooled rack, that was a single rack, to a cold plate solution. This provided an opportunity to get very familiar with liquid cooling, really developed an understanding of the differences, everything from the advantages and to what are some of the challenges of moving to direct liquid cooling. Once your data center has the hydronic infrastructure in place, so that's the facility supply and return taps, you can do a variety of liquid cooling combinations. That is what we have found with our experience. Rear door heat exchangers are more energy efficient than circulating the air throughout your entire data center, and we tend to use those for storage racks. However, the direct-to-chip solutions at the processor level offer improved energy efficiency, and we recommend those for compute-intensive racks. Both cold plates and immersion-based solutions are options. We understand your first transition to liquid cooling might begin with just a single rack and not your entire data center. This kind of start actually provides an opportunity to get familiar with liquid cooling and understand the options that exist out there. Everything from what it takes to operate from a staffing perspective, work procedures, and safety considerations. If you haven't already been working closely with your site operations team or plumbers or mechanical contractors, you will want to develop that relationship. It's also gaining that experience so the entire team, including system administrators, can get comfortable with liquid cooling. The Energy Efficiency HPC Working Group is a great resource to talk with people that have already deployed liquid cooling and maybe even do a site visit to one of their sites. So reach out to this community. And of course, supercomputing conferences like SC and ISC have a lot of liquid cooling hardware on the trade show floor. So take advantage of those opportunities. If you don't already have them, you will want to look for and obtain one-line drawings of the mechanical systems showing where water is being run to your data center floor. You might be surprised that it's closer than what you think. It might be there for your air handling units or your CRACs. You also need to know if it has the capacity to handle the additional load of liquid cooling. As you retrofit, you could think about tying into an existing facility loop for a demonstration rack. The assumption for a first testbed system is a single rack utilizing an in-rack CDU that requires a 1-inch facility water system connection, a supply and a return line. Suggest buying a rack from a vendor with servers already designed and configured for liquid cooling with a CDU included. We prefer to require the selected vendor be responsible for the secondary fluid system, from verifying fluid material compatibility to treatment of the secondary fluid and configuring CDU set points, along with the ongoing maintenance during a multiple year warranty. There are a few approaches to facility preparation to consider. Work with your site operations facility department to identify the closest source of facility water that meets the ASHRAE W class required for your testbed system. For a quick setup, if you already have supply and return facility taps nearby, deploying 1-inch diameter reinforced rubber hoses is an option to connect to these existing facility taps. Consider a manifold distribution system up front. This will have a higher initial cost, but will provide more flexibility over the long run if you plan to deploy multiple racks, so a lower total cost of ownership. When working with facility hydronic systems, the following are good practices to follow. Flush new piping sections with an adequate amount of water to remove debris and contaminants introduced during installation. Hydrostatic pressure testing, used to check for leaks before connections to CDU are made. Install high point valves to vent air from the system during fills or to assist with draining sections that have been isolated. Verify connection fitting types, whether imperial versus metric, and coordinate with all parties involved to avoid delays. Some commissioning considerations. We suggest you include facility-related measurements in acceptance test plan to understand and verify percentage of IT equipment load that is captured direct to liquid. This involves measuring the total power usage of your rack and calculating the heat load captured direct to liquid by measuring the delta T and flow rate through the CDU, and then comparing that to the total rack power. Assuming initial runs with a conservative supply temperature, you could also begin to explore elevating the secondary supply temperature to get a sense of the impact of facility infrastructure as you expand and document potential efficiency gains from elevated temperatures.